Hello friends, welcome to Susan and John Matthew. In this video, we're going to learn some extra important questions in Taylor and Laurent series. In the last video, we learned a very systematic method or the formula method for Maclaurin and Taylor. So if you read this question, just look at this question, you will be able to solve it with the same method that we learned in the last video. And by looking at the question, it is obvious we want the Taylor expansion, not the Maclaurin. So we find the derivative, the double derivative, triple derivative, etc., etc., etc. And our aim is minimum 3 non-zero terms. How many non-zero terms? Minimum 3 non-zero terms. And we will plug all these things into the formula and we have the expansion. You can pause the video and try it in the same method you learned in the last video. Yes, the video that like 10 minutes video. But this method is extra important and it will be very efficient for certain problem where finding derivatives are difficult. Not for this problem, but in some problems finding differentiation will be difficult. But everything works with the Maclaurin expansion of all these things. 1, 2, 3, 4, the blue, that is binomial series. Then the so easy method. So easy means sine will have odd power, cos will have even power. And of course the exponential function. You should be really good with these formulae if you want to apply method number 2. So what we do is, we look at the point at which we have to expand. So z equal to 2i. And all you have to do is take this 2i to the left side. And put u equal to that and z equal to this much. And now we write the function. Once more I'll repeat. You look at the point at which we have to do the expansion. Take this 2i or whatever be the number to the left and call it u. Find the value of z in terms of u and plug it into the function. Simplify, simplify, simplify. You can be 100% sure you will be forced to use one of the yellow, green or blue. Blue we will use when we have binomial expansion, and of course the green for trigonometric functions and yellow for the exponential function. Can you see? We have an exponential function and I just applied the formula. And that's it. I'm going to replace every u with z minus 2i. And can you see? This one and this one are the same. Okay, I'll give you one more example. Now look at this. We are going to expand f of z equal to cos z at z equal to minus pi by 2. 100% obvious this is Taylor. Anyway, on the left side, I have kept the method that we learned in the previous video. Find, can you see? We are finding 3 non-zero terms. And plug it into the formula, we get the expansion. But look at this, this is more efficient. So what did I do? I look at the point at which I have to expand, take it to the left side, call it u, write z in terms of u and plug it back into the function. Now I hope you remember cos minus theta. You must use pen and paper so that it will be very useful for your exam. So look at this, we have cos minus theta, that happens to be cos theta, and cos 90 minus theta is sin theta. And that's it, I applied the expansion. Okay, now let's go for a very important question. So once more, if you want, you can take a screenshot. You can take a screenshot of all these formulae. We need all the formulae. Now we'll go for the most important type. So let's go for the next problem. Expand the function f of z equal to z plus 3 divided by z minus 1 into z minus 4 at z equal to 2. Now look at this. You can apply the method you learned in the last video. But the problem is you have to apply U by V rule again and again and again and again to find the expansion. So we will not use that method. If you want, you can use it if you love differentiation. But in examination, you have to complete this problem within 10 minutes. So what do? I will take the point of expansion, take the number on the right to the left and call it U, and write Z in terms of U. Now I'll plug the Z value into the function. So I'm going to get U plus 2 plus 3, that will be U plus 5, divided by U plus 2 minus 1, that will be U plus 1, and U plus 2 minus 4, that will be U minus 2. Now you convert this into partial fraction. I hope you still remember partial fraction. So in one side of my note, I will apply partial fraction or method of suppression, whatever you like. You can call it A divided by U plus 1 plus B divided by U minus 2. But a warning, you are allowed to apply this method only if the degree of numerator is less than the degree of the numerator. Okay, so anyway, solving. I hope you still remember. You have to multiply throughout by this U plus 1, U minus 2. So you are going to get something like this. Okay, you put U is equal to 2. So this part will vanish. So we are going to get 7 is equal to 3B, or you'll get B is equal to 7 by 3. Similarly, you can plug in U equal to minus 1 and you'll get A is equal to minus 4 by 3. And eventually you're going to get something like this. Okay. Now note it down. I'll tell you something very important that will save you a lot of time in your exam. If they ask you Taylor expansion, and if you are applying this shortcut, you need the binomial expansion. And in the binomial expansion, you can see it is always 1 minus or 1 plus. It is not A plus B. That is binomial theorem. In binomial series, it will be always 1 plus or 1 minus. And that's very simple. Suppose I have A plus B. If I want, I can take A common or B common. Very simple. All I have to do is I have to multiply by A and divide by A. Now A is common. Now I can apply the same logic and multiply numerator and denominator by B so that B becomes common, and I'll get A by B plus 1. That will be B into 1 plus A by B. So look at this. We can always create 1. Now look at this. If I have A minus B, applying similar logic, I'll get A into 1 minus B by A. I can take minus B also. I can write this as minus B into 1 minus A by B. So it will be extra clear with this part. So once more, I'll repeat. Before you apply binomial series, you have to take one of them common. And if it is Taylor, you can be 100% sure you have to take the constant as the common factor. So I'm going to write this as f of z equal to minus 4 by 3. And the good news, here I can see 1 plus u. So it's already in the binomial version. Plus 7 by 3 multiplied by 1 divided by, look at this, we have two characters, u minus 2. In examination, don't get worried. You will always take the constant as common. If it is Taylor, write it in your brain, the constant should be pulled outside. If it is Lorentz, they will give you an annular region. So you have to manipulate the annular region and then decide. But in Taylor, in all the problems, the constant will be pulled outside. So I'm going to write this as minus 2u divided by minus 2 so that I can create minus 2 common. Now I'll take minus 2 common so that I get u by minus 2 plus 1. So this will be 1 minus u by 2. Now the next step is f of z equal to minus 4 by 3 into 1 plus u the whole power minus 1 plus 7 by 3 into 1 minus u by 2 the whole power minus 1. Look at this. You need a lot of practice for these type of problems. And if you look at the past paper in the old syllabus, there is not even one question paper without Taylor or Lorentz. And in some question papers, they even ask the definition. So be prepared with that. And you need to practice again and again. Okay, now that will be f of z equal to, we can just do the expansion. If you want, I'll show it once more. You can take a screenshot of this expansion. So this becomes 1 minus u plus u square minus u cube plus etc. You can write as many terms as you like. Usually we write minimum 3 non-zero terms. Minus minus is plus. That is how I remember that. So 1 plus u by 2 plus u square by 4 plus u to the power 3 by 8 plus etc. Okay, now you have to replace. Do you remember when we plugged in u is z minus 2? So that will be f of z equal to minus 4 by 3 1 minus z minus 2 plus z minus 2 the whole square minus z minus 2 the whole cube plus etc. plus 7 by 3 times z minus 2 the whole square by 4 plus etc. etc. If you want, you can simplify this or just leave it as such. Okay, now let's go for the next question. Lorentz series. In Lorentz series, you will be always given an annular region like this. Now this is called an annular region because mod z equal to r is a circle. What is modulus of z equal to r? It is a circle. If you want to understand the logic, you should go for the first video in complex analysis. In that video I told you z is x plus iy. So modulus of z will be root under x square plus y square. So this equation can be simplified into mod z square equal to r square, that is x square plus y square equal to r square. So I am able to see two circles, mod z equal to 1 and mod z equal to 3. And they are circles. Mod z equal to 1 means it's a circle with center origin radius 1. Mod z equal to 3 means it's a bigger circle. Can you see? This actually shows the region beyond 1 and less than 3. That is called the annular region. So in Lorentz series, they will always mention something like 2 less than mod z less than 3, or maybe mod z is greater than 3. They will give you an annular region, a finite region or an infinite region, but a annular region will be specified. Okay, so let's go for the first question. So they are asking, find the Lorentz series. In this question it is clearly given, find the Lorentz series of the function z square divided by z minus 1, z minus 2, 1 less than mod z less than 2. So look at this. This is not Maclaurin. This is not Taylor. Taylor means a particular point will be given. In Taylor, don't forget, a particular point will be given. But here an annular region is given. Anyway, the method is same. Convert this into partial fraction. Now I'm giving you a warning. Many students fall into a trap. Can you see the degree of numerator and denominator are the same? Degree means the highest power of z after expansion. So this has to be written as a plus b by z minus 1 plus c by z minus 2. Anyway, the remaining method is same, multiply throughout. So z square equal to a multiplied by z minus 1 z minus 2 plus b multiplied by z minus 2. I'll recommend you to pause the video, try it, and then compare it with my answer. C into z minus 1. Now I will put z equal to 1, and when I plug in z equal to 1, these two will disappear and I'll get b is equal to minus 1. Now I'll put z equal to 2. When I put z equal to 2, this and this will vanish, so I'll get c is equal to 4. And now I'll put some random value. I'm plugging in z equal to 0. So 0 is equal to 2a minus 2b minus c. Now I know the value of b and c, so I can solve for a, and I got a equal to 1. So look at this. I'm going to write z square by z minus 1 z minus 2 is equal to, that means the given function equal to a is 1 and b is minus 1 and c is 4. Once more, make it very clear, this is not Taylor but Lorentz. In Lorentz, they will give you an annular region. So the annular region is 1 less than mod z, and mod z is less than 2. Can you see? I can see the same number here. In Taylor, I gave you one guarantee. In Taylor, the guarantee is you should always take the number as common. But in Lorentz, there is no guarantee. Everything depends on the annular region. Everything depends on the annular region. Now, let's take a look at the formulae. So, look at all the formulae very closely. All these formulae will work only if modulus of this quantity is less than 1. Now, that is exactly what we are going to use now. Can you see? 1 is less than mod z. I'm going to divide both sides by mod z. And I'll apply the property of modulus. Oh, that means I want 1 by z. Now look at the other part. Mod z is less than 2. I'm dividing both sides by 2. Now I will apply the property of modulus. Now look at the denominator 2. So look at this. I want you to focus on this step. If you see z in the denominator, take z as common. If you see a number in the denominator, take that number as common. So I'm going to write this as f of z equal to 1 will be 1. No need to do anything with that. Minus, I'm going to take z as common. And here I'm going to take that number as common. One minus z by 2. Now that's it. Now just 2 more steps and you get the answer. This is a critical step. 1 by z, 1 minus 1 by z the whole power minus 1. And this will be minus 2 because this will get cancelled. 1 minus z by 2 the whole power minus 1. Now we are ready for expansion. Okay, now we'll just expand. It will be 1 plus 1 by z plus 1 by z square plus etc. minus 2 into 1 plus z by 2 plus z square by 4 plus etc. Okay, now let's look at the past paper questions. Now let's take a look at the past paper questions. Okay, so look at this. We have a question in Lorentz series. Can you see? A question in Lorentz series. Because they have given one annular region. Let it be any annular region, you have to create something less than 1. For example, if they give you mod z is greater than 3, then you should automatically understand 3 is a number greater than 2. And you'll create two inequations, mod z greater than 3 and mod z greater than 2. And from here you have to write 3 is less than mod z, 2 is less than mod z. And then you'll write 3 by mod z is less than 1, 2 by mod z is less than 1. So my point is, let it be any annular region, you have to convert it into the numbers given in the denominator. Okay, so what do I do first? Partial fraction. So let z plus 2 and z plus 3 is equal to a plus b divided by z plus 2. I will recommend you to do this question completely by yourself. Pause the video, try it and come back and check the answer. So I'm going to get z square minus 1 equal to a multiplied by z plus 2, z plus 3 plus b multiplied by z plus 3 and plus c multiplied by z plus 2. And I'll put z equal to minus 2, I'm getting b equal to 3 and z equal to minus 3, I got c is equal to minus 8 and I also got a equal to 1. You can compare these answers and comment below whether the answers are correct. Now I will write the function is, what is the value of a? 1. And what's the value of b? So plus 3 divided by z plus 2. Now minus 8 divided by z plus 3. Now comes the most important part. 2 is less than mod z and mod z is less than 3. I told you, you must convert it into the numbers given in the denominator. And you should always create less than 1. So 2 by mod z is less than 1. Mod z by 3 is less than 1. So mod 2 by z is less than 1. So it is obvious. Here we have to take z outside. And here z by 3 is less than 1. So it is very clear 3 should be taken outside. So one more step and we are ready to write the last answer. So z goes outside, 1 plus 2 by z minus 8 divided by 3 goes outside. So 1 plus z by 3 and we get f of z equal to 1 plus 3 by z into 1 minus 2 by z the whole power minus 1 minus 8 by 3. 1 plus z by 3 the whole power minus 1. Now you can expand it. Okay, now let's go for another question paper. Okay, again we have Laurent's. So what should we do? We have to factorize. So f of z equal to, you can use a calculator or otherwise, it is obvious, it is z minus 1 into z minus 2. Look at the region. I can see the numbers 1 and 2. Now what should we do? We have to convert this into partial fraction. So I'm going to write method of suppression. The degree of numerator is less. So if I put 1, I'll get minus 1 over here. If I put 2, I'll get 1 over here. Now I have to take this 1 less than mod z. So mod 1 by z is less than 1. So that means z is going to go out. So minus 1 by z into 1 minus 1 by z. And mod z is less than 2. So mod z by 2 will be less than 1. So 2 goes outside. Actually minus 2 is going to go outside. Minus 2 into 1 minus z by 2. And expand. Now let's take another question. It's same question. So let's move on. Same question. This is a different question. Can you see? Define Laurent series. I told you they asked the definition. Be aware of it. Obtain the Taylor series for... Okay, so look at this. This is not Laurent's. This is Taylor. So I'm going to write this as f of z equal to z divided by z minus 2i into z plus 2i. I'm not going to explain that step. All of you know that I square is minus 1. Simplify, you will get it. Since it is Taylor, I'm not going to use the method that I learned in the last video. I don't want to differentiate again and again. What will I do? I will look at the point at which I have to expand, take all the things to the left hand side and call it u, and write z in terms of u and plug it back. I'm going to get u plus I minus 2i, that will be u minus I, u plus I plus 2i, that will be u plus 3i. Now what should we do? Convert this into partial fraction. Anyway, I already did that partial fraction. Okay, pause the video, try it, and I'll be back with the answer. So you're supposed to get 1 by 2 by u minus I plus 1 by 2 divided by u plus 3i. Okay, now look at this. This is not Lawrence, this is Taylor. In Taylor, you can be 100% sure you will always take the constant outside, not this. In all the problems, you have to take the constant outside. So I'm going to write this as f of z equal to 1 by 2, 1 divided by minus I, 1 minus u by I, plus 1 by 2 into 1 by 3i, 1 plus u divided by 3i. Okay, long back we discussed this. 1 by I is minus I. Never forget it, it's very important. Or you can just type it in your calculator. Okay, now this becomes f of z equal to, can you see 1 by I, and there is a minus, so it becomes I by 2, 1 minus, can you see this u by I, again this 1 by I will become plus, and here again I can see 1 by I, 2 into 3 is 6, so that becomes minus I by 6, and again I can see this 1 by I, 1 by I will be minus, so that will be 1 by ui divided by 3, the whole power minus 1, and that's it. We are at the last step. F of z equal to I by 2 into u expanded, 1 minus iu plus I square u square minus I cube u cube plus etc. minus I by 6 into 1 plus etc. etc. Now don't forget, you have to replace u with z minus I. Also remember, I squared is minus 1, I cube is minus I, etc. Okay, now I want to discuss one problem. It'll be nice if you try this yourself. I'll give you an exercise. Expand the function 1 by z square minus 5z plus 6 mod z greater than 3. Okay, I'll give you a hint. First of all, you have to convert this into partial fraction, z minus 3, z minus 2, and I told you you have to create these numbers. So I'm going to assume, or I know 3 is a number bigger than 2. So I got 2 in equation, mod z greater than 3, mod z greater than 2. Now I have to write it in the form less than, 3 less than mod z, 2 less than mod z. Now the remaining you try it yourself and type and put the answer below in the comment section. So I'll be back with more videos, and we are going to start with complex integration from the next video. So till then, my friends, bye.